let's talk about this, degrees and radians. So right angle trigonometry, we were dealing with degrees only. So when you talk about right angle trigonometry, I'm sure you're talking about triangles, which means typically you, from like a geometry standpoint, you talk about degrees. Also in triangles, we know that triangles only add up to 180. When we think about circles, we think about 360 degrees, but you can have bigger degrees than that, than just one circle. The example they give you is snowboarding. If you've ever watched, the Olympics or anything, they will actually call off the degrees. A 540 is a trick, and it's actually 1.5 complete turns. And so 360 plus another 180, right, gives you the 540. And so the point here is that you can just, because it's circular, it is infinite. So you can have greater than 360. You can have greater than 720. I mean, it can just keep looping and keep looping and keep looping. All right. And so we start to think about angles in just a different way. And the first thing you want to think about then are the terms that they have right here. We know vertex, right? That's simple. We've learned that since geometry. The vertex is this point where the two rays meet. The initial side, that is the starting position. Now, initial side can be perspective. So if you think about when you've measured angles in the past using a protractor, depending on where you put that protractor was the initial side, and you had to be careful about which set of numbers you used on your protractor so that you didn't get the wrong angle measure. The terminal side is then where it ends, terminate, right here, terminal side. Now, standard position. When the vertex, so let's say we plop an angle and we put it on the coordinate plane. Standard position means that the vertex is at the origin, 0, 0, that the initial side is right here on the x-axis, and then it terminates somewhere out there, all right? This would be considered standard position. And so when we move to unit circle trigonometry versus triangle, right angle trigonometry, this is what you're going to start seeing is angles in standard position, all right? And so then you have positive and negative angles. So prior to this point, all of our angles have been positive because we've been talking about measurement, which makes sense, all right? But when we start talking about coordinate plane, positive and negative are just talking about the motion starting from the initial side and rotating. If you rotate from the initial side counterclockwise, that is a positive, all right? Think about how you count coordinate planes. This is your quadrant 1, quadrant 2, quadrant 3, quadrant 4. So that would make sense you're moving in the positive direction, all right? If you start at the initial side and you move counterclockwise, then that would be considered a negative angle or a negative movement there, all right? Meaning that you could actually have two angles with this that are actually the same exact angle but different measurements depending on how you're looking at it. So if I look at this angle to the right, if I were to go clockwise, this would be 1 degree measurement, right? Probably about, 120 or so. But if I were to look at the counterclockwise, it's going to be negative this way, all right? Negative this way. And so maybe like negative 240. So if I were to go clockwise, that's my negative movement. And I'd have to go a lot further in the negative than I would to have to go in the positive here to get to the same terminal side, all right? We're looking at degrees at first. We're going to move to radians in a minute. So when you think about degrees, 0 degrees would be right here at the axis of the x-axis here. And then as you move 30, 45, 60, 90, these are some common ones obviously that you learned on your chart here. You get to the 90 point and then 30 more degrees, 45 more degrees, 60 more degrees, and so on and so forth. And you go all the way around, a complete circle being 360 degrees. And then you could keep moving as it indicated, right? You could keep moving there. Now, something that you're not used to at this point is decimal degree form. Decimal degree form. So if you look at the top of page 232, you can get more specific than just degrees. So degree measures can be expressed using degree, minute, second form. All right, you'll find this in like navigation a lot. All right, so when you're navigating across an ocean, it is vitally important that you are specific to where you're going, because if you're going all the way across the ocean, being off even half of a degree will get you to the wrong destination, okay? And so when you look at minutes and seconds form, it's just getting more specific. Think of it like if you were to measure something in yards. Well, that's great, unless you need to be more specific than yards, right? If I'm talking about football, yards is fine. But if I'm talking about the measurement of this room, I probably want to be a little more specific if I want to like carpet in here as to yardage, right? Or if I want to do trim work, probably want to use feet and inches. And so that's what happens with minutes and seconds when you're talking about degree measurement, all right? And so you use the same concept as minutes and seconds, all right? So they've given us this example, 56.735 degrees, all right? That's one way to write it. We are now going to convert that from just decimal form to DMS, which means minute second, all right? Degree minute second. And so from decimal form to degree minute second. So we're going to take the 56, that's our degrees, and we're going to leave that alone. And then we're going to add to it the 0.735, and we're going to convert it to minutes. So how many minutes are in an hour? 60, and that's what we're going to do. We're going to multiply that by 60. Multiply that by 60, you get 56, that's still your whole number there, plus, and you get 44.1, and you'll notice they have this little dash above it, all right? The dash indicates minutes, all right? Minutes there, all right? We still have a decimal, and so we're going to take that 56 degrees and that 44 minutes, and we're going to add to it the 0.1 and convert it to seconds. How many seconds are in a minute? 60. And when we do that, we will get 56 degrees plus the 44 minutes plus the 6 seconds. And you'll notice it has 2 dashes. And so the way you would write this out, you would say that the 56.735 degrees can be written as 56 degrees, 44 minutes, 6 seconds. And that is a very specific measurement, all right? Very specific measurement. So we have 32 degrees, 5 minutes, 28 seconds, and we want to convert it back to decimal form, all right? And so when you're converting back, you're going to divide or multiply by the reciprocal. So I have this 32, that is not going to change. And then I'm going to add to it my 5 minutes. But remember, we multiplied by 60, so we need to divide by 60. All right? And for my seconds, we multiplied by 60 again, which means we have to divide twice by 60. Or we multiplied by 60 times 60, which is what? 60 times 60 is? 3,600, right? So for your seconds, you have to divide, because you multiplied to get to that point, all right? So you have to divide by 3,600 there. And so when you do all of that, your 5 times your 1/60th is 0.083. And your 28 times your 1/3,600 is 0.008. So you add all of those. And remember, you need to line up your decimals or use your calculator because you don't want to get that wrong. You're going to get 32.091 degrees. So that would be converting the other direction. We introduced the term radians. The measure of theta in radians of a central angle of a circle is equal to the ratio of the length of the intercepted arc as to the radius r of the circle. Yay. All right. So basically, the length of the arc is what they're talking about compared to the radius of the circle. Okay. And what happens is your measurement of your arc has a radius in it. So it ends up canceling pretty much, all right? And so you end up with basically just the circumference of this thing and how far you've gone with the circumference. And I'll give you the example. Down here, If we look at an entire circle, all right, we'll start with that one. An entire circle, that's 360 degrees. So what would that be in radians? Well, the formula to find the circumference or the measure of an entire circle is 2 pi r, right? And then we also have to divide by r because it's a ratio. So 2 pi r, they said radians is the length of it divided by the radius. So the length of an entire circle is 2 pi r, yes? And the radius is r. Well, what happens there? My r's cancel. 2 pi, that would be the radians of an entire circle, all right? So that's actually what happens. It actually starts being a proportion of 2 pi, all right? That's what radians is. You're literally just, if you were to take that angle and look at the length of that arc that's created, that is your measurement of that angle. All right, so here's another one. Half a circle, all right? 180 degrees, right? Well, if I were to say 2 pi r, right, I would end up canceling my pi. So let's just take the radian measure. We know an entire circle is 2 pi, right? So we take the 2 pi and we only want half a circle. So a half a circle would be 1 pi. All right? And so there happens to start this relationship between degrees to radians, all right? Radians is simply the measure of the arc that's created, the measure of the arc that's created. Let's look at this guy, 90 degrees. That is 1/4 of an entire circle, right? 2 pi times 1/4, pi over 2. Pi over 2 would be this length right here. Remember, pi is not a variable. Pi is a number, 3.14. Continuous, right? If we look at this guy right here, 1/6 of a circle, right? 1/6 of a circle, or 60 degrees. 1/6 times 2 pi, that's pi over 3. So that means if I were to stretch this out, the length of this would be pi over 3. And that's how we convert from degrees to radians. Now, think of it like feet and meters or something like that. It's just two measurements for the same angle, all right? If we were to measure something in metric, right, versus English, that's just two different ways of measurement. Or if you look at Fahrenheit versus Celsius when you're talking about temperature, it is just two measurements for the same temperature. This is just two measurements for the same angle. One is radians, meaning we're doing it in the pi form, and the length of the arc that's created, and one is in degrees, which is the movement form, okay? What happens though, when you have degrees and you need to measure something, you can't measure degrees, not with any type of linear measurement, right? I can't say, oh, go measure that with your yardstick and it's in degrees. We have a problem. And so when you start needing linear measurement and measure of the actual arc that's created, you have to have it in radians because that's a physical measurement that I can actually put my hands on. Degrees is not. Degrees is a movement, okay? And so that's where we started to have the need for measuring how much it's actually moving, and how much it's actually moving is that arc that's created. So there is a very easy conversion, but you need to memorize it, all right? If you are going from degrees to radians, you need to multiply by pi over 180, all right? You need to multiply by your pi and divide by 180, pi over 180. If you are moving from radians to degrees, you just multiply by that reciprocal, 180 over pi. So think of it this way. If you have it in degrees, you need a pi, so pi over 180. If you have it in radians, you need to get rid of a pi, 180 over pi. So look at these really quickly. All right, for the first one, it's degrees. We want it in radians. So we are going to multiply by pi over 180. All right, now I will tell you, you typically don't have decimals and radians at this point when they're converting. So they typically want you to leave it as a fraction of a measurement, not decimals. So you do need to do some reduction here, reduce your zeros out. What goes into 12 and into 18?
2.
And something bigger? 6. So that'll be 2 and 3. So you're left with, and that's over 1, right? 2 pi over 3. And that would be in radians. And your degrees is gone because this degree right here on the 180 canceled out this degree on the 120. Think about in measurements. Remember when you were doing conversions and you did minutes per second and you want to change from miles per hour? Your final thing would be in whatever conversion you were in. So this is radians. This next one, negative 45. The negative stays. We're going to multiply it by pi over 180. Again, you want to do some reduction here. Some reduction. 45 goes into both of those, by the way. And you're left with negative pi over 4. And that, again, is in radians. Converting the other way. 5 pi over 6 is in radians. We want it in degrees. We're going to multiply by 180 over pi. My pi's will cancel. My 6 will cancel with my 180. And I'm left with 150 degrees.
I like those.
All right. And then the last one, negative 3 pi over 2, multiply by 180 over pi. Again, we can do some canceling here. Right? And we are left with negative 270. So make sure you pay attention to your units, degrees versus radians, and make sure you pay attention to your positives and negatives. Go ahead and do those 4. Angles. So we talked about a little bit when we introduced angles here, but coterminal angles are exactly what it sounds like. Angles that end at the same point. Coterminal. They terminate at the same point. This does not mean that they go the same direction. It just means that they end at the same point. So 2 things can happen. I can have positive and negative coterminal angles here. So look at this termination point here, just like I said at the beginning. Positive alpha or beta, that would be negative, but they end at the same point. Those are called coterminal angles. Okay, so they start in standard position, they end at the same point. Something else that can happen is they could both be positive or both be negative. I have standard position here, alpha. Beta is also a positive angle, but it went all the way a 360 and made it back around to the same termination point. And so when you are finding, let's say I gave you an angle and they want you to find something that terminates at the same point, all you have to do is add a full circle or subtract a full circle and you will end at the same point, right? If you go 360, you're at the same place you started from, right? Which is why I hate the phrase, they made a complete 360. No, it's they made a 180, right? If you're talking about they turned around. 360, they're going the same direction, people, okay? So add 360 or subtract these 360 if it is in degrees. If it is in radians, what is a full circle in radians? So in radians, you add 2 pi or you subtract 2 pi and you have gone a complete circle. And you have found 2 coterminal angles. If you add 2 pi, right, that's a coterminal angle. If you subtract 2 pi, that is a coterminal angle because you've just gone a complete circle. All right? All right, so look at this one. 45 degrees. 45 degrees. So we have this guy right here. 45 degrees is exactly half of my 90. All right, so he'd be right there. 45 degrees, and they want me a coterminal angle. I'm going to take that 45, and I'm going to add 360. All right? Add 360, which is going to give me 405. 405 degrees is going to look exactly the same as that one. 405 degrees is going to look the same. This is my 45. My 405 does this guy right here. All right? Let's say they wanted a negative coterminal. I'm going to take that 45 and I'm going to subtract 360. And that's going to give me negative 315. This is coterminal. This is coterminal. What happens on the 315 is I start here and I go this way. That's 315 degrees. Okay? Add 360. That's coterminal. Subtract 360. That's coterminal. Look at the one in radians. I'm going to add 2 pi. All right? 2 pi. Not 25. Now, it's 2 pi over 1. So what do I need? That's a fraction. I need a common denominator. Multiply the top and bottom by 3. So I have negative pi over 3 plus 6 pi over 3. That's 2 pi. Right? So that gives me -1 plus 6 is 5 pi over 3. That is my coterminal angle there. All right, pi over 3 is about right here. Oh, negative pi over 3. Negative pi over 3 is about right here. So that means 5 pi over 3 would start here and end there.
Can you tell me how again you know where 5
Units, radius of 1. All right, let's say I wanted a negative coterminal angle here. I would take that negative pi over 3 and I would subtract 6 pi over 3. That would give me negative 7 pi over 3, which means it would, negative 7 pi over 3 would look like this. End at the same points. All right, so add a full circle, subtract a full circle. That is coterminal. So full circle is what you're adding and subtracting. Full circle for degrees and then for radians. Add a full circle, subtract a full circle. That's how you get coterminal angles. I'm not going to do that one. Example 4, all right? So when we talk about arc length, we want to know exactly how long that arc is that's created. Now, it's really simple when it's in radians because the only way you can measure length is in radians. We talked about this. You can't have a length measure in degrees, all right? Length measure can only be radians, all right? So the formula is very simple. The formula for the arc length is just your radius times theta. Theta is your angle measurement in radians, okay? For the first example, they gave it to us as pi over 4 in radians. They want the arc length. Well, it's my radius, which is 5, times my measurement of my angle in radians, pi over 4. That's rather simple. The answer is 5 pi over 4. Easy. Look at the next one. 60 degrees. Is that in radians? No. So because this guy is not in radians, I have to use not just my formula up here, I have to convert it as well. And so I'm going to take that 60 degrees, I'm going to multiply it by pi over 180, and then I'm going to multiply it by my radius, times 2. Now you can do it all at once. I can cross cancel here. 60, looks better. 60 and 180, 1 and 3, 2 is good, so we have 2 pi over 3. So when it is in degrees, you have to convert it first. You have to convert it first when it's in degrees. Degrees will make you convert first before you can go on. So go ahead and try those two. All right, check your work here. 2 pi over 3 and 2, 4 pi over 3. And if they want it rounded to the nearest whatever, you would round. In this case, they rounded that. For this one, 3 pi over 8. 3 pi over 8. Top of page 236. Top of page 236, we give some definitions here. Linear and angular speed. So think about it like a tire. It's the best description that you can have, or a time, like a clock. We'll talk about that too. The linear speed is if you were to take like one part of your tire and how far that one piece traveled. So if you were to put, some type of paint on it and release paint, how far would that paint go if it went? And so you have to consider the circumference of your tire when you are considering the linear speed. So linear speed is literally if you were to stretch out how far you went, which is what we typically do when we're talking about like miles per hour, right? We're talking about the linear miles over the number of hours, right? So this particular equation for linear speed is right here at the top. V, or your velocity, equals S over T. So what is S? S is what we got from the prior example, all right? So your S is going to be your angle measure in radians times your radius, okay? So if you look at the page prior, S is defined. Your theta, which is your angle measurement in radians multiplied by your radius, okay? Multiplied by your radius. Now, one thing I want you to think about when we're talking about this is that we're talking about things rotating, all right? And so a lot of times they will tell you how many revolutions it is, how many revolutions it is. And so when we're talking about revolutions, then so a revolution in this particular is an entire circle. We're talking about in radians. So how big is one circle in radians? So if we were to look at the circle that we've been doing, one circle in degree is 360. How much is one circle in radians? In degrees is 360 degrees. How much is one circle? Think about your coterminal angles. If you add an entire circle, what are you adding when it's in radians? For degrees, you add 360 and subtract 360. For radians, what did we have to add, subtract to get a coterminal angle when we added or subtracted one circle? 2 pi. So one revolution is 2 pi because all of this is done in radians. So if something goes around one time in radians, that angle will be 360 degrees in degrees, but 2 pi in radians, okay? So when you're thinking about what a circle means in degrees versus radians, you want to think about the fact that we are now not in the same measurement you've always known, all right? So typically, you would say this is 360 degrees, an entire circle. That is in degrees. We are now talking about a different unit of measure. So one circle in radians then is 2 pi, okay? So one revolution then would be one circle, 2 pi. 2 revolutions would be 4 pi. 10 revolutions would be 20 pi. All right, you're multiplying every revolution by 2 pi to figure out what that theta is or how many circles you have gone when you have rotated your tire, okay? So one revolution is 2 pi. The length of your arc that is created is going to be whatever your measurement is for your theta times your radius, all right? And then your linear speed then is going to be this entire arc length. It could be 3, 4, 5 circles, or 5.5 circles, or 150 circles, right? However many times that particular object turned, okay, times your 2 pi, and times your radius. That's going to be this S here. If you take your entire length and divide it by how long it took you to go, that will be your linear speed. We do the same thing when we're driving a car. If you go 200 miles in 2 hours, your speed was 60 miles per hour. Your total time amount that you traveled divided by your total time, right? So now we're just converting it to how far that piece traveled when we're talking about rotations, okay? Linear speed. The other thing that we talk about in this particular section is angular speed. Angular speed. Now, this is different than linear speed. Linear is talking about if I were to take an object and roll it, how far did it go in a linear motion, all right? A line. Angular speed is how far did it rotate, all right? And that's angular. How many angles did it rotate in a certain amount of time, all right? And so your angular speed then is defined differently. Angular speed is going to be your theta. Your theta is still calculated the same way. If they give you revolutions, your theta is however many revolutions times 2 pi. 1 revolution equals 2 pi, all right? So whatever your theta is, whatever your angle is, it's going to be however many rotations you did times 2 pi. That's going to be your theta. And you're going to divide that by the amount of time. Okay, so your angular speed is your total degrees, but in radians. So your total angle measurement in radians divided by how much time it took you to go that many angle or that many radians, okay? So let's look at the example here. just really quickly, I want to show you that they have specific letters for linear speed versus angular speed. Here it isn't as obvious. It looks like a V, but if you look at your homework, it actually looks almost like a cursive V. They do it almost like this. It's actually Greek letter nu, all right? So this is a Greek letter, nu. And then this one is your omega, all right? So that's an omega, Greek letter omega. And so in your book, a lot of times it'll just say find it, and they'll just give you the nu for the linear speed or the omega for the angular speed, and you just need to know that they're asking for angular speed or linear speed based on the Greek letter that they gave you, all right? So just pay attention to that in your instructions. During one delivery, the tires rotate at a rate of 140 revolutions per minute. Find the angular speed of the tire in radians per minute. So my angular speed is going to be my theta over my time. All right? Pay attention to your units. They told me revolutions per minute. They want it in radians per minute, okay? So I need to convert my revolutions to my radians, all right? So if I have 140 revolutions, one revolution is 2 pi. How do I calculate my theta based on 140 revolutions? How much is one revolution? 2 pi. How much is 140 revolutions in pi? All right, so 280 pi, all right? Each revolution is worth 2 pi. So 140 should be 280 pi, all right? That's my theta. So I have my numerator here, 280 pi, all right? That is per how long? How long did it take me to go 280 pi radians? 100 revolutions per what? Minute. So per 1 minute, right? So my answer here for my angular speed is going to be 280 pi, and typically they put it in decimal form. So when you put that in decimal form and just multiply, you get 879.6 radians per minute. All right, on part of the trip to the next delivery, the tire turns at a constant rate of 2.5 revolutions per second. Find the linear speed of the tire in miles per hour. All right, so they want linear speed. Linear speed has a different definition, right? Linear speed is going to be my S over my T. So I have to calculate a few things. My S is theta times R. They gave me the diameter, right? So I can easily figure out my R, my radius. They did not give me theta. They gave me revolutions. So I have to convert revolutions to radians. How do I do that? How do I convert revolutions to radians? We just did it. One revolution is 2 pi. So what am I going to do? 2.5. So they told me it was 2.5 revolutions. So how is that in radians? 2.5 times 2 pi is going to give me what? 5 pi, right? We're going to leave it in pi for now. So that is going to be my theta, right? That's my theta. Then I'm going to take my theta and I'm going to find my S, right? S. So what is my radius then, according to that picture that they gave me? If 30 inches is my diameter, what is my radius? 15. So to find my S, I'm going to say what my theta was, 5 pi times 15, which gives me what? 75 pi radians per second, right? All right, so let me do this again. It erased all of that on me.
So I said when I was like,
I know, let me do it again. So this is inches. We're gonna convert 3,600 seconds to 1 hour. We're gonna convert 1 foot and 12 inches, and then we're gonna convert 1 mile to 5,280 feet, all right? What you wanna do when you do conversions, if it's been a while since you did them, is you wanna make sure you have converted everything. So my inches canceled out with inches. My seconds canceled out with seconds. My feet canceled out with feet. So I'm left with miles per hour, and that's exactly what I'm trying to find, okay? And then of course in your calculator, you can just multiply across. 75 times pi times 3,600 divided by, make sure you use parentheses when you do your denominator, divided by open parentheses, 12 times 5,280. So in your calculator, it will look like this. You will say 75 times pi times 3,600 divided by 12 times 5,280. How many miles per hour when you round to 1 decimal place would you get for this trip?
13.4.
13.4 miles per hour. So check your first one. Your angular speed is going to be in radians. Your linear speed is going to be in whatever your question requests for it to be in. So you're going to take your rotations, 3.5. You're going to multiply that by 2 pi. That's 7 pi radians over. That was 1 second. So it is actually in the units you need it in. You just need to, if they ask for it in decimals, 22.0 radians per second. All right. If the DVD player overheats and the disc begins to rotate at a slower rate of 3 revolutions per second, find the disc linear speed in meters per minute. So it is currently has a revolution of 3 per second. Yeah, so you are going to take your 3 and you are going to multiply it by 2 pi. And that will give you your theta, which is 6 pi. All right? We then have to multiply that by our radius to get our s. So our s is going to be 6 pi times my radius, which is 60 millimeters, right? So what is my s then? 360 pi millimeters, right? If I put that over my time per 1 second, that would be my linear speed in millimeters per second. What do they want it in?
Meters per minute.
Meters per minute. So how many seconds are in 1 minute?
60.
So I'm going to say 60 seconds. Make sure it's always opposite of where you have it. Over 1 minute. All right. And then my next conversion is going to be my millimeters. How many millimeters are in a meter? 1,000. So 1 meter, we'll just do M there because is 1,000 millimeters. All right. And then I'm just going to double check to make sure I have converted accordingly. The millimeters cross out with millimeters. My seconds cross out with seconds. I will be left with meters per minute, which is what they ask for, meters per minute. So you multiply across, you will get 360 times pi times 60. All of that divided by 1,000. And you should have gotten approximately 67.9 meters per minute. Area of a sector. So first of all, what is a sector? I like to explain this because everyone will relate. Like if you were to have to find the area of a piece of pizza, that is a sector, okay? All right, and so you're basically with your arc length, that is just the crust of the pizza, right? That's how long that is. But the sector is the whole entire pizza piece, the slice of pizza and what that area would be. And so we've done this, you would have done this in geometry. The area of a sector of a circle with a radius r and a central angle theta is 1/2 r squared theta. 1/2 r squared theta, where theta is measured in radians. So that's important that theta is measured in radians when you do this particular formula, because remember, you can't really measure out degrees. You measure out inches and feet and everything like that. And so radians is what you need to have it in when you do that. So find the area of the sector of the circle. It's very simple when you have it in radians. It's simple either way, but we're going to say 1/2. We're just going to plug it in. 1/2, my r here is 3, so 3 squared, times my theta, which is already in radians, 7 pi over 8, all right? And so when you multiply that across, we have 9 here times 7. That's going to give us 63 pi on top, 18 or 16 rather on bottom. And if you were to put that into your calculator and approximate it or round it, 12.4 square centimeters. Remember, area is two-dimensional, okay? Two-dimensional, so it's centimeters squared, square centimeters. Easy enough. You just have to memorize the formula. Now, if you don't have it in radians, you have to add in the conversion when you do your theta. All right, so let's look at the next one. It says, find the approximate area swept by the wiper blade shown if the total arc length of the windshield wiper mechanism is 26 inches. All right, so I'm going to do my formula again. 1/2. My radius here is, they did there. That's confusing. All right, so the total length of the windshield wiper is 26 inches. So all the way across here is 26 inches. And apparently they didn't make it clear, but they're saying this is 16. So from here to here is the leftover, and that's where we're getting our 10 inches. All right, so if the entire thing, I'll do it in a different color. The entire thing is 26 inches, and this part is 16. What's being left over right here to create this particular wedge that we are trying to solve for is your 10, all right? 10 inches. They should have labeled this 16 a little better. All right, so our radius is 10 inches. So we have 10 here, squared. Now our theta has to be in radians. It is in degrees. So I'm going to take that 130 degrees, and how am I going to change it to radians? So pi over 180. And so this is what it's going to look like when I do this particular one. All right. I am going to multiply across. You'll get approximately 653.5. If you leave it in radians, in pi form, you just need to make sure you do all of your conversions here and reduce it. But when you put it all the way across and multiply it out, 653.5, just make sure that you convert it if it's in degrees. If it's not in degrees, you're gonna have to convert it. If it's in degrees, you're gonna have to convert it. So just try 2 of those, A and B. So for the first one, the formula is 1/2 r squared theta. And they gave it all to you. 1/2, 1.5 squared is 2.25 times 3 pi over 4. When you put that into your calculator, you get approximately 2.65 or 2.7 square feet. The next one is in degrees. So we have to say 1/2 r squared, 6 squared, times 50, but we have to convert it. So multiply that times pi over 180. And again, you get rounded to 15.7 square meters when you do that one.